Familiar with drought factor curing and grass fuel load. So you can see in the drought factor on the left that this is built from a lot of our rainfall observational stations, and it's a little bit more smooth than perhaps you would expect, given some of the terrain in the curing is so different there. But the drought factor is kind of smoothed out because of the location of our gauges. So we've got different resolutions in model data that we're using. So the drought factor being calculated on a grid that is more smoothed than perhaps the curing information that we're getting from satellite. So we're getting that satellite curing on the 6 kilometre by 6 kilometre grid coming into our GFE system, but it's first of all coming through via the Bureau to the Rural Fire Service, who are doing some quality control, and they're also receiving it on a finer resolution than what we are using in our forecasting system. So they have access to finer scale curing from the satellites than what we're able to use in our current system. So they're doing the quality control and then upscaling the resolution to the resolution that we need. And as you can see on the far right, the grass fuel load in New South Wales is just assigned on a per fire area basis, so it's not showing any local terrain and variations at all. So although we're producing in the final output for the fire danger rating pixels that vary over 6 kilometre grids, the adjacent ones to one another may be quite different. You have to understand that the underlying grids and information, we've got different amounts of resolution and quality going into that, so they're not necessarily 100% all calculated the same way. And so once we've created our grids of wind and temperature and fire danger rating, we produced the written forecast, which was based on the written forecasts that we used to produce before we moved to a graphical system. So we still kept point location information for the points that people were used to using to make their decisions from, but we're also now moving to an area-based rating system, and you're probably all familiar with them, and those of you who work operationally are seeing these every day. So that's the general routine that we go through to produce the ratings each day. And we also have an important role in communicating our fire weather forecasts. And we are able to do this to the general public with our gridded information through METI. And we also have available through to the fire agencies, in particular at the RFS, they're receiving all the grids, not just the ones that are available on METI, through our FTP service. And as a result, they can extract that data and use it in a lot of their fire behaviour prediction systems as well. So if you want more information about those, you can let me know and I'll speak to you after. So now come to the role of the Rural Fire Service meteorologist. They spend a lot of their time communicating the forecast to the agencies, as no doubt you're all aware. So as we've mentioned before, the main things that they would be communicating over the shorter term and longer term are the forecast uncertainties. So this is a thing that we're not able to produce in gridded or worded forecasts at the moment as well. So a lot of that communication is coming from the Rural Fire Service meteorologist, who's then briefing decision makers there who are promulgating that information. We also have those briefings open to all fire agencies for New South Wales and ACT, and if the Rural Fire Service meteorologist is not there, not available, there's always the option of phoning the Sydney office of the Bureau, and you can get a briefing from the fire forecaster who is on. So, assisting with planning for prescribed burns, the meteorologist will work closely with the planners, and they will cover the outlook for the season, but also more specifically for the week ahead and the trends for the following period. And they help to identify periods of time, maybe a couple of days, maybe a couple of hours, that might be more risky or might present more opportunities for fire hazard reduction burning. And again, important in communicating the forecast uncertainty. And they, as well as running a few briefings, they put together weekly fire notes on the outlook for the week as well. The Fire Service meteorologist has been working with the planning team led by Simon Heemstra, who you might want to talk to further about this. They've been developing some prescribed burn tools. So this is a little map here of a pilot program. So it's suggested to look at cases where we might want to do some burning in the future, and looking at weather conditions and also fuel conditions that might make certain areas of the planned burn locations either favourable or unfavourable. So these are looking at things like, what will the forecast FFDI be, what will the winds be, and what flame heights we might expect as a result of weather conditions and fuel. And has there been recent rainfall? Will we expect to see more rainfall? And as a result, colouring in each of these pixels as possible, marginal, poor, or blue for low fuel availability. So this is one of the tools that has been in pilot stage at the moment, I think. So I'm going to speak now more about specific hazard reduction burning. So the meteorologist who's outposted at the RFS and also the meteorologist in our city office are able to discuss the limitations of the gridded weather that may be available for the period in question. So we'll look at things like when fire behaviour analyst staff are running their fire spread predictions, is the weather model that they're using to drive that consistent with what we're thinking, and are there any alternative scenarios that should be considered? And we may also consider things like the gridded weather that we are producing, as Jeff mentioned earlier, is on a pretty coarse scale compared to the local effects that may influence the burn. And with that FTP data available, we're also able to extract weather data from the grid for point locations, but we have to be aware that it's for a nominated altitude, and it won't be taking into account differences in height or things like that. And that's one of the reasons why we also produce manually spot fire weather forecasts for both hazard reduction burning and for wildfire forecasts. So this is our database where we store the information for burn locations. As I mentioned before, we're now requiring latitude and longitude and altitude to locate the fire accurately and to have a bit of a look at the near-by terrain, which we would do often using Google Earth at the moment. I have had a couple of cases where I've been given a latitude and longitude which doesn't line up with the town nearby, and I've been asked, well, can't you just use that anyway? No, we actually do need to know where the fire is. So we have the fronts, troughs and wind changes often can be marked using our wind change chart, and we'll mention on the special spot fire forecast for the location in question what we think the likely timing of that change will be reaching the fire ground. We'll also provide a discussion of alternate scenarios. So what would happen if the change came through a little bit later? You know, the hot, dry conditions would last a little longer and may last until such and such a time, for example. And I suppose other things we're also mentioning but aren't able to capture perhaps well in the very specific discrete forecast that we have is some of the local variations over the terrain. So your fire's not just burning in one spot, it's burning over an area. The terrain changes over an area. We can only give you, in the current forecast, one wind direction. So we have to give you descriptions for likely variations over that terrain, and I'm sure you're all familiar with some of those. So for example, we'll be seeing accelerated airflow around the sides of a mountain, and we're more likely to see funneling effect between two mountains, and we can see turbulent effects behind the lee of the mountain as well. Other effects we can see and have noticed in weather observations is flow over a mountain. You can get some separated flow on the upside and of the mountain, as you can see in the first picture, and we have observed some rotor winds down around Bega when we've had some mountain wave conditions over the southern ranges, and so you can get an easterly in amongst a westerly flow, and these are the kind of things that we need to specify directly for individual special fire forecasts. This is what it might look like. I'm afraid this is the text-only version, as I couldn't find the nicely formatted version. And as you can see there, just an individual one-time step for 1 point. So I think a good way to go for the future would be to be able to capture a lot more of that wind variation over the terrain, especially for larger fires. We can perhaps do it with this resolution that we have at the moment that are more than 6 kilometres. We could see different winds described, so that you might see on top of the mountain range, you might see westerlies, and as you go down the eastern side, you might begin to see an easterly sea breeze coming in, and perhaps it would be helpful if we could describe those with specific values, which could then be used for fire simulations. So I'll just give you a little overview of what I talked about. So first of all, I mentioned how we produce our fire danger ratings using our graphical forecasting system, which some of you may have seen before, and I also spoke a little bit about the role of the Rural Fire Service outposted meteorologist and the fire weather forecaster in providing briefing and extra commentary for forecast locations, and also touched on prescribed burn forecasts for specific burns.